Yeah, so this Ubuntu PDF, so I'm not very that realized for now. But hi everybody, my name is Bogdan Stoica. I'm a postdoc at UIUC. Today I'm going to talk a little bit about artifact evaluation and how can we improve that and make it less tedious for folks to participate. Of course, this is joint work with our colleagues at Microsoft Research. My postdoc host Yanin Zhu and I are collaborating with Sean Hanway and Xinyu from Microsoft Research. These are Microsoft Research Asia and Microsoft Research Vancouver, Canada, not Vancouver, US. All right. So I'm guessing everybody knows or has a bit of an idea what artifact evaluation is, but just to get on the same page, there's a lot of text here, but basically it's a community effort to help publish research be more reproducible and reusable by the next generation researchers, and also making sure that the code, data, and other materials behind the papers are readily available, functional, and can be rerun by independently by other folks. And of course, when you run it, the claims don't completely collapse, or at least that's the idea. And it provides a few advantages for those people that go through artifact evaluation as a peer review process, so as part of the paper review process. Of course, it provides an independent validation of these claims. It facilitates independent reuse and research extension, and you get something to brag on about. Your papers get stapled with a few badges indicating the degree of reproducibility and reusability of your research. And of course, this is a very important process, but it's also a very tedious process. And you've heard today why reproducibility is tedious and all the problems. I won't repeat it here. I would just say that in the context of artifact evaluation, there's this great paper written by a few of our colleagues, especially Solal, somewhere in the middle of the author list here, is the one that led this effort about what they learned doing artifact evaluation at a major systems conference in our field, Eurosys, over 5 years. And some of the conclusions are that this is a very manual and cumbersome process. Review deadlines for the committee and for authors are incredibly tight, so there's not enough time to basically go through all the motions. But the biggest blocker is the fact that most of the time, reviewers are not unable to find, build, compile, or execute those tools, those research prototypes within reasonable effort. And I want to talk a bit about my experience with organizing artifact evaluation. I'm not going to name the conference, but again, a large systems conference. And this is very fresh statistics. I just computed them this morning. I'll keep it loose so you don't pinpoint the conference. But in this conference, we evaluated 50 plus artifacts. This generated 1,600 messages between authors and reviewers, so it's a huge number. And this is a lower bound. But the most surprising things, well, two surprising things. The first one is that, I don't know if I have a mouse here. That's okay. So the one surprising thing is that half of the discussion is actually spent on fixing bugs with the scripts, fixing misconfigurations, hard-coded paths, IPs, and whatnot. And mostly operational clarification and functional clarification. So only 14% of these messages are actually dedicated to science and to discuss whether or not the results support those claims, those hypotheses, and what the authors can do to improve the confidence of the reviewers in this result. So I was quite surprised by that. And of course, this don't add to 100%. There's a bit of stuff in between, the AE chairs begging reviewers to finish review on time. So that's the...
Yes. I just want to stop, Bogdan, and sort of say that I totally agree with this from my own experience of an A chair, that A seemed like a functional exercise rather than scientific exercise.
Right.
And I think that's a very important thing that we should recognize, that we are scientists, we are not DevOps engineers.
Right.
Yes, go ahead. Sorry.
Can I ask a question?
Yes,
please.
I just want to understand a little bit better this. So these are paper. You get it, the papers. It's like being reviewed.
Yes.
And then you have to ask the authors. These messages are to the authors say, "Hey, this is not running."
Right. So basically, the way it happens is that you have the regular peer review, where a committee of technical program committee will get the papers and render a verdict, which ultimately should be accept or reject. And for the accepted papers, what happens nowadays in multiple communities across CS is that authors are invited to artifact evaluation, which is a similar peer review process, but not for the paper, for the prose, the narrative itself, but for the materials that led the authors to those conclusions. And these authors will package them up, send them to the committee will try to run, and then will render a verdict. Which is not accept or reject, but rather some degrees of reproducibility. Right now, I don't know any conference that would actually reject the paper if stuff is not reproducible. And I'm lucky we didn't have that discussion recently, in at least the sessions that I organized, because that's a very difficult discussion to have. But so far it's optional, but we need to improve the process, because it's the only way to increase confidence in what actually are presented. Hope that answers your question. We can take more offline. So given these numbers and given this much time spent on operational things instead of functional things, instead of the science itself, we can ask the question, what can we do about it? And we have somewhat of a solution for papers. We ask authors to submit papers in a certain format. We restrict the number of pages. We restrict the font. We restrict the the space between rows and margins and whatnot. And we could do something similar for artifacts themselves, and ask the authors, for example, to have a comprehensive README. Multiple pages, right, where they describe everything from dependencies, configuration, different types of configurations. How do you run the experiment, and what kind of data you expect? If you run on a different machine with different specs, do you expect any deviation? Tests, because every step needs to be tested. So we could ask authors to do all that, and then we can also ask them to containerize it. So it's a push button thing for more or less for the committee, right? But the problem is that now we're shifting the burden from reviewers mostly to the authors. And it's also not only this shift, but there is a mismatch in incentives. As researchers, we want to publish. Well, that's our currency, right? We're not engineers. We are engineers, but our primary job is research, publishing papers. So maintaining software beyond the paper being published is not something that is on our to-do list. And props to people that manage to do that. Props to people that manage to do that with almost all their papers. So it's incredibly difficult. Containerizing things doesn't fully capture the whole environment. There's no external dependencies and no you cannot, for example, easily run a different set of a different data set. So there's still work for the committee to do, and we might end back to square one. And then so given all of these restrictions, and given that we cannot just burden authors to doing all that, what our proposal is to use AI to offload these tedious manual parts of the artifact evaluation process. And here's how we can do that until we figure out the better solution. From a reviewer's perspective, when they try to evaluate an artifact, there are a few broad steps that they need to do. They have to
set up the environment, the experiment environment that the user use. So this means installing dependencies, environment variables, making sure that the right software is installed and right software and hardware boundaries are respected. It has to build the code from source because, of course, authors can give you precompiled binaries, but trust that that's food for thought. I'll answer that question. And essentially, you need to compile from source, build, install, and run some small sanity checks to make sure it's actually, the code was compiled. You need to install benchmarks and download data sets, install benchmarks that were used by the authors to evaluate their claims and reach some conclusions. You have to run the experiments, and luckily authors are very diligent about it, and they provide either steps or scripts to run these experiments, but you still have to manually commands. And then you have to display those results, and finally, after all this, you get the science, which is what we call, code paper or tool artifact paper alignment, making sure that what's in the paper is actually implemented by the artifact, making sure that if you get to different results, they don't change the conclusions and the hypothesis of the paper, and these deviations are expected, maybe different hardware, different software, and whatnot. But you see, I've talked for about 2 minutes on this slide, and only 10 seconds is dedicated to the last part of science. Most of it is operational. So why not offload it to AI? Like, AI is very good at trying multiple things until it succeeds, and then producing a report, maybe even fixing things. We have so many coding agents nowadays, commercial and research and open source. It has to, we could use AI to mechanize these tedious manual steps, and and that's what we're currently trying to do. And in order to do that, we need kind of 3 ingredients. We need to create a framework and the data set benchmark framework, whatever you want to call it, to evaluate these AI agents and make sure that they actually can follow these steps. And there's no fundamental limitations, and probably we need to develop better, LM science before using it for artifact evaluation. Then design an agent or multiple agents, evaluate that and refine based on step 1. And finally deploy it and have some community adoption and support. So this becomes something that reviewers and authors could use as a tool in their toolbox on a regular basis when they submit for artifact evaluation. Right. So how does this work? Well, what we're doing right now is first creating this framework to evaluate AI, and this is surprisingly, we thought is going to be complicated, but it's actually surprisingly simple once you get down the artifact evaluation process to steps and stages. So we took an artifact, we take the README of that artifact, and usually because authors want the badges, right? So they do a reasonably good job at explaining what the artifact does and how it runs and everything. There are bugs, but at least there's a good starting point. And from that README, you can actually kind of separate the different stages, the experimental environment setup, building the code, installing data sets, and running experiments. And in order to evaluate how an agent actually does at these stages, what we did, we create, it's a bit pretentious to call it a DSL, but a pseudo DSL, where you can, as an author or us as the benchmark creators, you can specify the constraints, requirements, and restrictions for each phase. For example, for environment setup, we might say, well, you're successfully done with this step if your Docker version is 24.0, your GCC version is 13.2, and your make version is 4.3. I made this number up. That the version doesn't exist. Don't quote me on that. And if these requirements are met, that means you declare victory for this stage, and you can move to another stage. And this is simple because you can have an AI to say, well, yeah, I set up the environment, and then you run this DSL, said no, you didn't, or yes, you did, and you move on to the next thing. So we did that for several artifacts. The process is tedious but doable, and created a benchmark, which it's it's still in stealth mode, but probably in a week or two would be accessible. I'll have a QR code at the end. And took this artifact and augmented them with these evaluation or check scripts for each of the 4 stages. And then we created a runtime system around this benchmark. So you could take a repository and you can take an agent and ask the agent to, I'm sorry,
Yeah.
5 minutes, yes. Oh, I have 5 more slides, so I thought more of a discussion than slides. So on top of this benchmark, we created a runtime system where you could bring in, this is containerized, right? You can bring in an artifact with code and a README and steps and guidelines and whatnot. And let's ask the agent to read the README, read the code, and try to reproduce results. We don't give too much instructions to the AI, but or we give as little instructions to the AI as we give to the human evaluators, right? And then the AI does its thing, and at some point declares victory and says, yes, I've done it, I've reproduced those results. You can find tables, figures, and whatnot in this subdirectory. And then we bring in those tiny scripts that we wrote, those requirements. So we remove the agent from the system so it doesn't get to see the tests and evaluation scripts, and we run them. And based on what these scripts are telling us, we produce a report. How many stages the agent has managed to successfully pass, and how many sub-stages it passed, and where it had difficulty and whatnot. And of course, we provide score based on how many broad stages it managed to pass. So we have an idea, which artifacts are difficult for the AI to do, which stages were difficult for the AI to successfully pass. And if you have multiple agents, as you do, right? Some agents might be better at set up the environment than running your results scripts. Right. So with this framework, we have this framework, and we're about 2 weeks out from releasing it, releasing the benchmark, the runtime, and a small agent that people can use. But what we actually need is deployment and community support. And we have a Slack channel that you can join if you're interested in this type of research. That we'll post, and I hope that if the link doesn't work, let me know. Where we're going to post updates. There's going to be a blog post and Twitter. I actually have a paid Twitter account just for announcing this and writing more than 144 characters. Then I'll cancel my subscription. I think it's worth it. We're also deploying this agent to an upcoming conference. We're not going to use it to actually evaluate and assign badges because, well, we need time to prepare authors for this kind of change. But we're going to do a kind of a shadow evaluation where we're trying to figure out if what the human reviewer did versus AI kind of matches. And if the human spent half the time trying to get the authors to fix bugs, could the AI do that and within one clean report that you send to the reviewers and to the authors? And maybe you also, the AI can make suggestions. Okay, this path is hard-coded, this script has a bug, this particular configuration file is missing. And maybe instead of spending half the time of the committee's time haggling over these small nitpicks, maybe half the time will be spent on actually doing this code audit and artifact audit and make sure it aligns with the paper. Right, and on that good note, thank you so much for listening. Yeah, and I'm happy to take questions.
Yes.
So is this, I mean, this sounds great. Is this, I guess, I had 2 questions, but maybe I'll ask the one. Is this just for computer science? Because I see these like everywhere. Like every publisher would like to have something like this, because there is a company that tries to do this very unsuccessfully called Cold Ocean. I don't know if you hear it, but it sucks, or they don't do any of this. But is it this be generalized?
This is not exactly like Code Ocean. I mean, I let Bogdan.
Yeah, I know, but I think that's what they would like to go. I think we need something like this.
So the short answer is could be for any science. We're doing it for computer science because it's easy to have this type of breakdown and then create those benchmarks that you can actually evaluate agents. The problem with having an agent reproducing stuff is that you cannot trust it, right? You need a way to verify that it actually. Let me give you an example. One of these might not be one of these on this slide, but one of the artifacts we were trying to convince Claude Code to reproduce had a lot of steps and was running for 48 hours. But Claude would just say, I reproduce stuff in 30 minutes. Until we realized that Claude actually found some of the tables, the raw tables that the authors used to generate the figures. It found it in some obscure directory that the users committed by mistake. And once it figured it out, it would trick us it would run up until the running the experiment script, and then would take those results, put it in the table, and declare victory. So it's doing half the work and then taking a shortcut. And my worry is that if you don't build a proper evaluation and training ground for these agents, you're not going to have any meaningful results. You need to trust the results. So sorry, this is kind of a long answer to say, well, if you can divide it in clear stages, if you divide your experiment setup into clear stages that can be programmatically validated, like, yes, I've done step one, and then there is a set of commands that you can run independently and validate if step one is actually done, then yes. Yes.
So I have a question that what is the objective that you are thinking? So which will sort of maybe provide answers to the validation question that you have, because if are we saying that these agents are a replacement for the entire AE committee?
No.
Right. So we are saying that it's a human AI collaboration,
yes.
Right? All we are trying to do is reduce the burden of the reviewers and help them with things. So if the example that you give, which is saying that, well, it has not reproduced, or Claude is saying it is reproduced, but we are not sure that exactly. So can't the human actually at that point go, would that require more time than a normal AE process?
That's actually a good question, and I don't have a very informed answer about that. My hunch will be that the time will shift from fixing bugs and these functionality issues to actually get into the details. Are these results supporting are these results actually being result from running the tool or not? Are these results supporting the hypothesis, even if they differ a little bit? And that, I still think it's a human, it needs human intervention. Even if you ask AI, if you have ChatGPT
right.
to give its opinion about it, you still need a human. So to answer your question, what this does is shifting the workload towards the science part.
Right. I think a metric, which is the number of messages that you have, if that can be reduced, right. I think that itself is a big sort of success in some senses of reducing the burden on the reviewers.
Right.
Yeah. 1600, which is very typical for a systems conference.
Right.
1600, 2000 messages that are happening just for this.
Just for yeah.
There is one more question over there.
So these agents are well known for non-deterministic behavior, say LLMs or agents or anything. So in terms of these agents on the artifact evaluation, so we can build evaluation agents in order to evaluate the artifacts. These evaluation agents can be reproduced. Like, my question is like, can we reproduce the results of this evaluation agent, because these are not deterministic in the nature? So can we reproduce that evaluation agent itself on the artifact? I mean, I'm just curious because we are also working on the same thing, and I have this question like, can you reproduce the agent generated evaluation? Is there a way?
So that's an excellent question, and the short answer is you cannot faithfully reproduce everything because they are non-deterministic. But what you can do is you can have checkpoints and you can validate their work. We provide coarse-grained checkpoints. When the agent declares that it has installed all the dependencies, we actually have a list of all dependencies, and you can go and type with the name of the dependency in terminal for every single dependency. You can even for packages in Python or some libraries in Java or C++, you could in theory go and check if all of them have been installed and then validate the work like that. And then you can also record what the agent is doing, and you can manually verify command by command the trajectory that got from starting the artifact to declaring that it has installed the environment. Now, can you reproduce? Can you replicate the process faithfully in the sense that if you run the agent again, would it follow the same steps? No, I don't think so. Does it have to reach the same point, which is yes, I've successfully installed the experiment environment? Yes. So to me, as long as you have like a series of checks that you can, independent of AI, that you can deploy and validate its work, and then audit the way it got there, because it might trick you. It might find the answer on the internet. These artifacts are on GitHub. These papers are open source and freely available. Nothing stops an AI agent to search the web, find the table in the paper, parse the PDF or whatever format, dump it in a CSV file format in the directory where the tool expects or would have produced it if you would run it, and then just pause for 48 hours. There's nothing stopping AI doing that, right? So it's on us to validate all these steps. I don't have a good answer how to validate those steps.
I do.
Okay.
Okay.
Yeah, okay.
So we are there right next.
Yeah.
Okay.
So
That's
let's
actually a really bold statement. I do not.
no,
I'm working on one.
Okay.
No, that's okay.
Let's thank Bogdan.
Thank you.